Okay, so we are going to be starting notes 33. So this is the beginning of the mole unit. You should have kind of gotten a glimpse of what the mole is on Friday as well as in the warm-up today, but still, we're going to talk about it right now. We're also going to do a little quick review of things we talked about in our last unit because if you don't know these, we really can't understand what we're going to eventually do with moles. So let's quickly review. Here we go. So the subscripts in a compound refer to the number of atoms present in that compound. So remember, a subscript is like if I have H2O, that is a subscript, saying I have 2 hydrogens. Eventually, you'll have to remember what the coefficient was. Like it was 2 H2O. Remember this number right here, that 2 in front is a coefficient, and it goes to everything it's in front of. But the subscript is telling me directly about the element that it's next to, so hydrogen. So let's kind of practice that for a second. If I'm looking at this compound right here, and I want to count these atoms out, make sure I know how to still count them. So I have Fe, I have chromium, and I have oxygen. I want to know how many of each one I have. So Fe, iron, has a 2 subscript. There's nothing else in front of it, so there is 2. There's 2 irons. For chromium, it's in parentheses, however, and that 3 outside of it multiplies whatever subscript that is there. So if it was a 1, it'd be 3. But right now, chromium has a subscript of a 2 that's multiplied with that 3. So 2 times 3 is 6. So there's 6 chromiums in this compound, 6 atoms of chromium. And then for oxygen, same thing, 3 times 7, that's a much bigger number. So 3 times 7 is 21. There are 21 atoms of oxygen in this compound, iron chromate. Okay? So let's kind of go back on how we count because that will be important in a little bit when we move forward in the next couple of days. Next, just some kind of things to highlight for when we're doing these numbering down here. It says ionic compounds. Let's remember an ionic compound is a metal that joins a non-metal. So in an ionic compound, they have a lattice structure, looks like a crystal. So they are said to consist of formula units. So that's what their little groupings are called, is a formula unit, the smallest ratio of the atoms still being bonded together. So literally, this is the only time in this class where you can funnily write this on your paper and it actually be accurate. The shorthand to write formula units is FU. That is actually what it is. That is its scientific shortening syllables, okay? So you are allowed to write it on your paper if it is a metal or non-metal compound, an ionic compound. For molecular compounds, they consist of discrete molecules. So they're little groupings of their compounds. Remember, molecular is a non-metal joined with a non-metal. They are called molecules. And then things that are by themselves. So elements by themselves are called atoms. So they're just like, that's what we've been saying all along, just an atom of it. So we have an atom. They're not bonded to anything, so they're not a molecule, they are not a formula unit, they're just an atom. So if I'm looking at some examples here, so we have CO2, will be the number of atoms of each element. So first off, I have carbon and oxygen. Carbon has no subscripts, no parentheses, so it's just 1. There's 1 carbon atom in this compound. Oxygen has a 2 for a subscript, so it's 2. So that's me counting my CO2. Now, is it an element, is it an ionic compound, or is it a molecular formula? So it's not an element, because it's not by itself. It is a type of compound. Now, ionic means metal, non-metal. Molecular means non-metal, non-metal. So this carbon is in the non-metal side of the periodic table. So is oxygen. So it's a non-metal, non-metal compound, which would make it molecular. Good. Try again. Molecular. Okay. Now, if it's molecular, then what I call the little pieces of it in the smallest form, just CO2, just 1 C, 2 O's bonded together, each of those would be called a molecule of CO2. Okay, the next one is silver. Okay, well, silver is by itself. It doesn't have any numbers. It's not diatomic. There's 1. There's 1 atom of silver. If there's only 1 element, then it's an element. This is not a compound, not bonded anything. This is an element. And elements we call individual elements. They're just by themselves. Being silver, we call them atoms. And this last one, chromium sulfate. So we have Cr, we have S, we have O. Trying to figure out how to count these. So chromium has a 3, so there's 3 of them. Sulfur has a 3 outside in parentheses that goes to both of them and multiplies with the subscript that they have. So 3 is multiplying by, we can't see it's a 1, but it's understood there's at least one of them. So 3 times 1 would be 3. So there's 3 sulfurs. And then for oxygen has a 4, so 3 times 4 is 12. So there's 12 oxygen atoms inside that overall compound. Now, as an element, is it ionic or is it molecular? Well, it's not an element. It's got more than one element in it. It's bonded. It's a compound. Chromium is a metal, and sulfur and oxygen are nonmetals. So that's a metal non-metal compound, which would make it ionic. Things that are ionic is you can funnily put Fu, or you can write out formula units, mean the same thing. That's just what they're called, formula units versus molecules. All right, let's scroll down. So that was our quick review, because you do have to be able to count your atoms very well, or we really can't move forward into the things we're going to do with the mole. But let's just briefly talk about the mole today. Barely going to get into it, just I want to tell you what it is. So the mole, I know it sounds weird when we have the mole that's an animal, we have the moles on our face. That is not what it is. Why they decided on this name, I don't know. It is a silly name. But what it means is the amount of a substance that contains 6.02 times 10 to the 23rd particles. Now, that is a giant number. But here is the reason. We needed a way to count atoms. We cannot see atoms. We cannot count them one by one. They are way too tiny. So Avogadro, that was his last name, Avogadro spent a lot of time trying to figure out a way to count groupings of atoms, be able to measure them out precisely in a way that we could use them in a chemical reaction and use the right amount. Because if you haven't noticed in any of our lab demonstrations, you do have to have the right amount. If I do not add enough of this or enough of this, then the reaction will not occur. Same thing with our last year where we had to balance things. If it's not balanced, then the reaction's not going to take place. So it's not actually going to make it more stable. So you have to have enough going on for the reaction to occur. So if you're trying to create a medicine by mixing two things together and you want that reaction to occur and you don't want to waste any product, then you have to be able to measure out the right amount of product. The way we do that is with Avogadro's number. It is a high-level concept, an even higher level than me to understand how this number works so perfectly, but it does. It works amazingly, and it's set up on the periodic table in literally the perfect way to be able to weigh out the right amount of substance to have a chemical reaction work. And we'll explain that more throughout the day. But the way you got to think about the mole is the way you think about any counting number. If I said I have a dozen apples, then I would say, how many apples do I have? 12. I have 12 apples. If I said I have a pair of shoes. Well, how many shoes do I have? 2. I have a pair of them. Okay, so those are just terms. Those are just vocabulary words that immediately make you think a number. Like triangle, tri means 3. You know it has 3 sides. Just any of those English things that mean a number. Mole is the same thing. Mole is just a counting number, like dozen, like pair, like few. So like it's telling you a number, and the number it is telling you is 6.02 times 10 to the 23rd. Okay, so I know it's a big number to be told, but that's what a mole means. It just means I have that many of something. So if I say I have a mole of puppies, okay, so I say I have a mole of puppies. And then you're like, okay, how many puppies is that? Well, mole means 6.02 times 10 to the 23rd. So it means I have 6.02 times 10 to the 23rd puppies. That's how many puppies I have. Now, there's not that many puppies on the planet. That's why we don't count other things with a mole. I wouldn't count anything else with a mole except for atoms, molecules, and formula units, because they are so tiny, I actually need to have that many things to even really be able to see them. So let's kind of write this down. So if I have 1 mole of carbon, carbon is an element. It's just one single element. So its representative particle is atoms. So we're saying I have carbon atoms in a jar. If I have 1 mole of carbon atoms, how many carbon atoms do I have? Well, I would have 6.02 times 10 to the 23rd carbon atoms. Okay? That's all a mole means. It's just I have this many of that thing. So if I have 1 mole of sodium chloride, which is NaCl, sodium is a metal, chlorine is a non-metal. So it's an ionic compound. So its representative particle are formula units, or Fu. Now, how many formula units of sodium chloride do I have if I have a mole of them? Well, it's easy. It's just like if I had a dozen. If I had a dozen of them, I'd have 12. Well, if I have a mole of them, then I have 6.02 times 10 to the 23rd formula units of NaCl, of sodium chloride. And lastly, if I have a mole of carbon dioxide, CO2, then that is a molecular compound that's a nonmetal with another nonmetal, so it's a molecular compound. Their representative particle is called a molecule, so it's grouping by molecules. So if I have a mole of CO2, how many CO2 molecules do I have? I have 6.02 times 10 to the 23rd molecules. And there isn't really a short way to write this. You have to write molecules. If you write mole, well, that's short and that messes you up. Don't do that. It is molecules. You need to write the whole word. Molecules of CO2. Okay, and there we go. That's all we're going to cover today is just what is a mole. A mole is a counting number. It's how we count really, really tiny things like atoms in groups of 6.02 times 10 to the 23rd. Now, how do I weigh that out? We're going to talk about that tomorrow. So it's actually very simple, just on the periodic table, but we will discuss more how to do that tomorrow.